Hello, parents and students. Welcome to the first edition of Math is Still Math. Today we're looking at the 7th grade study guide for the second 9-week exam, and we're going to be going through it problem by problem. I highly recommend that you pause the video, each problem, and try to solve it before you watch me work it out. And then while I work it out, check your own scrap work against mine, and just see how you did. You might actually get more correct than you'd think. With that being said, let's get into it and start with problem number 1. Okay, so I've got my scrapbook ready here. I'm looking at the instructions, and it says here to choose the best answer for each question. So for number 1, it says if x equals -1 and y equals -3, then 5 parentheses x squared minus 7 plus y parentheses equals whatever. This is a basic substitution problem where it's giving me values for two different variables and then an equation or an expression where I just have to plug stuff in. So the first thing I'm going to do is rewrite the equation on my scrap paper here. So write down 5. First of all, I number my paper always, so I can go back and find it later. Number 1 is 5 parentheses x to the second power minus 7 plus y in parentheses equals nothing. Now, I have to take the values for x and y and plug them in where they are in the actual expression itself. So instead of having x, I'm going to put in this -1. So that'd be 5 parentheses. And then this is going to look a little strange, but I'm going to encase my -1 in a little set of parentheses. -1 to the second power minus 7 plus, and again, y is going to -3. I'm going to put it in its own little set of parentheses. Strictly speaking, that is not always required, but I've always found it better, and it's just more organized, especially when there's an exponent involved, as we'll see here in a minute. Okay, so let's unpack this. The order of operations is, please excuse my dear Aunt Sally. What that means is I've got to do anything that's inside parentheses first. And I've got a lot inside this set of parentheses, so I'm going to have to ignore this 5 for a little while. And I've got to get done everything that's on the inside first. This E means anything with an exponent needs to get done before the rest of that stuff. So I've got to figure out this right here, this -1 to the second power. If you don't know how exponents works, I'm going to be multiplying -1 times itself twice. Well, it's actually 1 times -1 twice, but for the sake of this moment, here's what we're going to be doing. This is going to be -1 times -1. That's what we should be thinking. So negative number times a negative number gives us a positive answer. That's just a rule. Negative times negative equals a positive answer. So -1 times -1 would be +1. So I still got this 5. So -1 squared would be just 1 minus 7. Adding a negative number is the same as subtraction. So I can just write -3. Okay? And you'll see anything I haven't used, I just keep writing it down until I have a chance to use it. Again, I need to do parentheses first, so I need to do this 1 minus 7 minus 3 before I do anything with the 5. Well, 1 minus 7 would be -6. I'm at -6. -6 minus 3 would be -9. So this would be 5 times -9. Now, if you didn't know this, whenever you have a 5 or anything mashed up against parentheses, this is a moment to multiply. So 5 times -9 would be -45. And it looks like that means the answer is C, -45. Let's get into problem number 2. Okay, number 2. What is the value of the expression if x equals -10 and y equals -2? Again, this is just like number 1. It's a substitution problem. So the first thing I'm going to do is write down the actual expression that I've got here. So it's 3x to the second power minus 1 plus y. And now I'm going to write it again, but I'm going to substitute in the values for x and y that the problem gave me. So x is -10, so it'll be 3 times -10 to the second power minus 1 plus, and then y is -2. I encased that in parentheses to be more organized. Now, this is again, please excuse my dear Aunt Sally, parentheses, exponents, multiply, divide, add, subtract. This is called the order of operations. It's just our math language of what we do first, second, third. And we don't have, it says parentheses, but we don't have any operations inside those parentheses. The parentheses are only there to be organizational tools in this problem. So really the first thing we've got to do is the exponent. And that second power is only on the -10. It has nothing to do with the 3. -10 to the second power means I'm multiplying 1 times -10 2 times. So really, we need to think of this as 1 times -10 times -10. That's what you need to be thinking about that. That is 1 times -10 times -10. So negative times negative is a positive. So that would be 3 times -10 times -10, that would be positive 100 minus 1. And then again, adding a negative number is the same as subtraction. So minus 2. Now, order of operations. I need to do, so multiplication and division always come before adding and subtraction. 3 times 100 would be 300 minus 1 minus 2. Again, anything I haven't used, I just bring it on down until I have a chance to use it. Okay, so 300 minus 1 is 299. Minus 2 would be 297. And it appears that means my answer is going to be C. Let's get into the next problem. Done my problem number. Keeping my paper nice and organized. Number 3. Okay, here we go. Which option is equivalent to 4 parentheses 3x plus 3? Okay, this is not a problem where we're actually going to have an answer. A solution and an answer, I think, are different. When you want an answer, it's like, I don't know the answer, it's 5 or something. This is more of just, I need to know how operations work, and what this is testing you on is called the distributive property. So I'm going to rewrite my expression, 4 parentheses 3x plus 3. The distributive property is a way of utilizing factors. Essentially, this is 4 times everything that's in this set of parentheses. So I'm going to multiply. That's what this means. Whenever you have a term mashed up against a parentheses, that's multiplication. I have to multiply 4 times both of these terms. So 4 times 3x would be 12x. And 4 times 3 would be 12. So what we are looking for is which one of these guys up here actually comes out to be 12x plus 12. And once we find it, that is going to be our answer. Okay, so so A, 4x. Okay, so 4 times 3x would be 12x. So that'd be 12x plus 3. No, not A. B. Okay, so right here, I'm looking at this. 4 times x would be 4x, and 4 times 3 would be 12. So that would be 12 plus 4x plus 12 for B. 4 times x is 4x. 4 times 3, it's just more distribution. 12. Now, this, I can combine these like terms So that would end up being 4x plus 24 altogether. No, that's not the same. It's not B. So C. Okay, so if I'm going to do the distributed property here for C, 2 times 6x would be 12x. And then 2 times the 6 would be 12, so 2x plus 12. I think we have a winner. I am almost positive it's going to be C, but I can never leave it. I have to work them all out just to make sure I didn't mess something up. So for D, this is just combining like terms. What that means is you can put whole numbers together. You can put negative numbers with other whole numbers. You can put anything with an x with anything with an x. Basically, you get to add things together as long as they have the same variable to the same power. So 3x, 3x, and 6x would make 12x. Because 3, 6, 12. But 3 and 6 only add up to be 9. So that's why it's not D. So for problem number 3, I guess our answer is, yep. C would be the equivalent expression. Let's move on to problem number 4. Which option is equivalent to 16x plus 24? Okay, well, I guess what we're going to do is just work out some distributed property stuff here and see which one comes out to be 16x plus 24. So number my paper, always. Okay, so A is 2 times 8x plus 12. B is 4 times 10x. You'll notice that I'm saying times when you see these parentheses, because that's what mashing things up against parentheses is. You're multiplying. And then 8 times 2 plus 3x. I'm not going to bother listing D. If none of them work, we know it's D, but we'll see. Usually that is not going to be the case. Alright, so I've got to multiply 2 times both terms. 2 times 8x would be 16x. And 2 times 12 would be 24. Oh, right out of the box. Nailed it. I'm pretty sure it's A, but I'm going to work out the others anyway. 4 times 10x would be 40x. So we know that's wrong. So 8, we have to distribute, multiply it by both. 8 times 2 is 16. And 8 times 3x would be 24x. So, no bueno. The answer for number 4 is A. Done. Let's move on to problem number 5. Number 5. 6 plus 3 parentheses x plus 4 end parentheses is equivalent to blank. Okay, so what I'm going to do here is I'm going to take our expression they gave us that we start with, and I'm going to actually do the distributed property and combine like terms to see what it actually comes out to be. So let's start off with 6 plus 3 parentheses x plus 4. Okay? Now, I'm going to do the distributed property first because, please excuse my dear Aunt Sally, parentheses, I have to do parentheses. There are no exponents, but what's inside the parentheses, I would do this first, but x plus 4, I can't do that because I don't know what x is. So multiplication division comes before adding and subtracting, so this is multiplying. So I'm going to end up with 6 plus, now 3 times x would be 3x, and 3 times 4 would be positive 12. Now, combining like terms means putting things together, they can go together. 6 and 12 are both whole numbers. They can add together. So I'll have 3x plus 18. Okay, so now we know what we're looking for. We need to know A, B, C, and D, which one. Oh, wait. Check that out. 3x plus 18. I'm almost positive the answer is going to be C, since that is exactly what we got. There's one on here I want to check out, though, and that is A. 3x and a plus 6 plus 7, so this would be 3x plus 13 altogether, so nah, that's not going to work. So yeah, we did a distributed property, we combined like terms, and it turns out the answer is C. Let's get into problem number 6. Okay, so for problem number 6, I'm going to number my paper. 4 parentheses x plus 3 n parentheses plus 3 parentheses 5 minus x is equivalent to blah. So, okay, so this is an order of operations. Do you know how to distribute sort of problem? Pause here. Hey, I'm in the middle of recording. Can we, okay, thanks. It's easy to edit out. I appreciate it. I don't think I have that much trash right now anyway.
Okay.
All right, number 6 has 4 parentheses x plus 3 n parentheses plus 3 parentheses 5 minus x n parentheses, and that is equivalent to, okay, so let me unpack this. Basically, it's gonna want me to show that I know how to do the distributive property, and then combine like terms, and then my answer should just be there. So I'm gonna write down the expression 4 parentheses x plus 3 n parentheses plus 3 parentheses 5 minus x. And now we're off to the races. I need to start doing my distributive property like right away. So I need to multiply 4 times both terms, and I need to multiply a positive 3 by both terms. Well, 4 times a positive x would be 4x. 4 times a positive 3 would be positive 12. Positive 3 times a 5 would be plus 15. And positive 3 times a negative x would be negative 3x. It's important to remember that if you multiply a positive number times a negative number, you get a negative product. Always remember that. And now I need to combine like terms. Something I like to do to help me see things, I underline anything that has an x to the first power, and then I circle my whole numbers. So let's go ahead and do the powers of x first. 4x combined with a negative 3x is the same as subtraction. 4x minus 3x, so that's going to leave me with 1x. Mathematicians are so lazy. I could write a 1 here as a coefficient, but it's just 1x, and we just don't even bother writing the 1. So that's x. So 12 plus 15 be 27. X plus 27, is that one of our answers? It is. Sweet. So distributive property, combining like terms, the answer 6 is A. Let's get into problem number 7. Okay, problem number 7. Write it down on my scrap paper. 4x plus 3 plus negative 3x plus 7x. Ugh, that's a mouthful. Again, this is just trying to test and see whether you can combine like terms. So 4x plus 3 plus negative 3x plus 7x minus 6x. Double check to make sure I didn't leave anything out. No, it looks like I'm good. Okay, so the first thing I'm going to do is I'm going to go underline anything that has an x attached to it. 4x, negative 3x, 7x, and negative 7x. And then I'm going to circle any of my whole numbers. Okay, so now it's really a lot easier for my eyes to see what I need. So let's do all the x's first. So, okay, so 4x minus 3x, I'm at 1x, plus 7x, I'd be at 8x, minus 6x, I'd be at 2x. Let me double check that. I'm at 4x, and I take away 3x, so now I'm at 1x. Then I add 7x, now I'm at 8x. Then I subtract 6x, so now that leaves me at 2x. And then this positive 3, it can't combine with anything. Is that one of my answers? Oh, it is. Sweet. So this is just a trial to see if you know how to combine like terms. Let's get into problem number 8. Okay, here's number 8, negative 10. Oh, I'm not even going to bother reading it. It is a giant long list of things to see if you can combine like terms. So, step 1 is to write it down very carefully, don't leave anything out, and make sure the powers and all the signs are correct. Okay, so, negative 10 plus 3x minus x minus 7x plus 5x plus 7 plus 2x. Ugh. How many terms is that? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I think we're good. So now I'm going to underline everything that has an x on it. 3x, x, negative 7x, 5x, and the 2x. And then I'm going to go back and circle anything that's just whole numbers or integers. Okay, so let's do everything with the x first. 3x, okay, so 3x minus x, that's, this is really a 1x, and if it makes you feel more comfortable, you can fill that in. 3x minus 1x, I'm at 2x. Minus. 3x minus 1x, I'm at 2x. Minus 7x, now I'm at negative 5x. Plus 5x, I'm back at 0. Plus 2x, I should end up at 2x. I'm gonna run back through that. So 3x minus x, okay, so right as of here, I'm at 2x. 2x minus 7x would put me at negative 5x. Negative 5x plus 5x would get me back to 0. 0 plus 2x is 2x. Yeah, I'm pretty confident it's 2x. Negative 10 plus a 7 would be negative 3. Is that one of the answers? Oh, it is. That's always a good feeling. So, combining like terms, keeping very careful track of your negatives. The answer to 8 is B. Let's get into problem number 9. Okay, number 9, 8x plus 3, blah, blah, blah. Okay. Again, this is going to be a lot of distributive property, a lot of combining like terms. Let's just make sure we write it down correctly before we get started. Alright, so number 9 is 8x plus 3 parentheses x plus 5 n parentheses minus 5 parentheses x minus 4. Okay. Now, according to please excuse my dear Aunt Sally, the first thing I've got to do is whatever's in parentheses. The only problem is I can't do anything when one's a variable and one's just an integer. So that's not possible. I don't have any exponents. Now I've got to multiply and divide. Well, this is multiplication. I've got to distribute these two terms correctly. So this 8x is just going to be stuck on. There's nothing I can do with it just yet. Positive 3 times x would be 3x. 3 times 5, that'd be plus 15. Now this is where it gets tricky. This is a negative 5. You have to remember that's a negative 5. Negative 5 times x would be negative 5x. Now negative numbers times negative numbers yield positive products. So negative 5 times negative 4 is going to be a positive 20. Okay. Distribution done. Now it's just combining like terms. Let's underline everything that has an x on it. 8x, 3x, and negative 5x. Okay, well, and then let's circle the integers. So I got a 15 and I got a 20. 8x plus 3x is 11x. 11x minus 5x would be 6. No. 11x minus 5x. Yeah, it'd be 6x. 15 plus 20, that'd be plus 35. Is that one of our answers? Ah, sweet. So it looks like the answer for 9 is A, 6x plus 35. Let's get into problem number 10. Well, okay, so number 10 has 4 parentheses x minus 7 n parentheses plus 8. Same old, it's the same skill. Can you do the distributive property and can you combine like terms? And if you can do both, you can get this right every single time. Let's write it down carefully. 4 parentheses x minus 7 n parentheses plus 8. Distributive property, 4 times x and 4 times negative 7 has to come first. So that'd be 4x minus 4 times 7 is 28, so that'd be negative 28 minus 28 plus 8. I can combine these two guys because they both don't have any x's on them. So that'd be 4x minus 28 plus 8, that'd be minus 20. Is that one of our answers? 4x minus 20? It is. Bam. The answer number 10 is D. Let's get into problem number 11. Okay, true, false. Okay, so when we say true and false in math, we just mean, does it make sense? Because if it makes sense, then it's true. And if it makes no sense, we say false. So we're going to do some substitution because they tell us that x is equal to 6. And they give us this equation. So I'm just going to take this 6 and plug it in over here where the x is. So 5 parentheses x minus 4 n parentheses equals 26 will become 5 parentheses 6 minus 4 n parentheses equals 26. And now we just have to figure out if this makes any sense. Please excuse my dear Aunt Sally. Okay, so we do what's in parentheses first. So 6 minus 4 is 2, so that'll be 5 times 2 equals 26. So now we can do multiplication and division. That means that 5 times 2 is 10 equals 26. Does this make sense? No. They don't equal each other. So the answer is false. B. Let's move into problem number 12. Okay, same situation here for number 12. We just need to plug in the 7 for all the x's and then see if the equation comes out to be balanced. So 2x plus 4 equals 18 will become 2 times 7 plus 4 equals 18. Order of operations is I multiply first, so that'd be 2 times 7, which is 14, plus 4 equals 18. Well, 14 plus 4 is 18. And yeah, that makes a lot of sense. 18 does equal 18, so the answer to this one is true. Let's get into problem number 13. Okay, so 13 is again a substitution true-false question. So we're going to write out our equation for number 13, write down our number, always be organized. 6 times x plus 5 n parentheses equals negative 7. When x is equal to negative 2, so that'd be 6 parentheses negative 2 plus 5 n parentheses equals negative 7. Okay, so please excuse my dear Aunt Sally. Parentheses have to come first. So negative 2 plus 5 is 3. So that'd be 6 times 3 equals negative 7. 6 times 3 is 18. That doesn't make any sense. 18 does not equal negative 7. So, not happening. Answer's false. Let's get into problem number 14. Okay, so 14 says 3x plus 9 equals negative 6 when x is equal to negative 5. So we're going to substitute in the negative 5 for all the x's and then see if it's a balanced equation. Let's see what happens. So I'm going to write down 3x plus 9 equals negative 6. Then I'm going to go ahead and do the substitutions. That'd be 3 times negative 5 plus 9 equals negative 6. So now we do the multiplication first. That'd be 3 times negative 5 is negative 15 plus 9 equals negative 6. Well, negative 15 plus 9 is negative 6. So, it's a balanced equation. That means it's true. The answer is A. Let's get into problem number 15. So here we are at 15. I'm going to have to do some substitution and then do some distributive property and just see if this thing balances out. So I'm going to start off with 10 parentheses x minus 6 n parentheses equals 120. And now I've got to substitute in the value of x, which is 12. So that'd be 10 parentheses 12 minus 6 n parentheses equals 120. Please excuse my dear Aunt Sally. I've got to do what's in the parentheses first. So 12 minus 6 is 6. That'd be 10 parentheses 6 n parentheses equals 120. Now I get to do multiplication and division because there is no exponent. 10 times 6 is 60. Whoa. I don't think so. So, since 60 does not equal 120, the answer here is false. And that is the answer for 15. Let's get into problem 16. Okay, problem 16, the dreaded word problem. Oh no. Guys, every problem is a word problem. It's just sometimes we speak it without writing it down. There's no big issue here. A teacher has 4 different students. Typo alert. A teacher has 4 different students to write an equation with a solution of x equals 4. Which of the following students correctly wrote an equation with x equals 4 as the solution? So what we got to do here is we got to plug in a 4 for these x's and see which one comes out to be true. Hopefully it's only one, so here we go. So problem number 16, organize my paper, always number my work. So 2 times 4 plus 6 equals 2. Well, 2 times 4, that'd be 8 plus 6 equals 2. Well, 8 plus 6 is 14. That doesn't equal 2, so it's...
Teachers and students, let me
Pause.
interruption. Miss Lowis, could you please report to Miss Collins' classroom? Miss Lowis, could you please report to Miss Collins' classroom? Thank you.
Let's try B. That'd be 2 times 4 minus 9 equals negative 1. Well, 2 times 4 is 8. And 8 minus 9 actually is negative 1. I think we have a winner. I think it's B, but just because I need to see it through, I'm gonna do them all. C is, so that'd be 2 times 4 plus 2 equals 10. Well, 4 plus 2 is 6. That'd be 2. So 4 plus 2 is 6. So 2 times 6 equals 10. Well, that'd be 2 times 6 is 12. So that's no good. Lastly, D, which is negative 2x. 2x, which is 4, plus 8 equals 4. Don't think this is going to make sense. We have to do multiplication first. That'd be negative 2 times 4 is negative 8, plus 8 equals 4, but negative 8 plus 8 is 0. Yeah, that doesn't make any sense. Negative 2 times 4 would be negative, yep, nope. So the answer is definitely B. Let's get into problem 17. Which equation could be used to solve the problem below? Amanda, okay. So on this one, I'm not going to be using my scrap paper as much as I am just going to be underlining and writing on my quiz itself. Amanda decided to save the money that she earned babysitting to buy school clothes. Amanda wants to buy 2 pairs of jeans. Okay, so this one I'm going to underline 2 pairs of jeans that cost $32 each. Then 3 shirts that cost $18 each. And a jacket that costs $54. Okay, so whenever you see the word each, that's a multiplicative word usually. So 2 pairs of jeans. So I'm looking for something like 2 times 32. I heard that. Then I heard 3 shirts. So that'd be 3 times 18. I heard that. And then a jacket. Now when it says a jacket, A is a number. A is just one of something. So that'd be 1 times 54. Okay, so as I'm reading, that's what I heard. I heard 2 of something that were $32 each, 3 of something that were $18 each, and then something that was $54. And when you're buying, you just add everything together. So that'd be 2 times 32 plus 3 times 18 plus 54, something like that. Which one of these has that? It looks like... Yeah, it looks like C has everything we want in it. And so that would be what was it? 2 pairs of jeans are $32 each. 3 shirts are $18 each, plus the $54 jacket. Yeah, the way you'd figure out the price of the shopping trip would be C. Let's get into problem 18. Okay, another one of these, which equation could be used to solve the problem below? Okay, so as I'm reading, I'm just going to underline the stuff I think is important. David went to a lot of events during the past year with different groups of friends. He went to a concert, that's one, that cost $32. He went to a concert that cost $18, and then to 2 festivals that cost the same amount each. Ooh, the word same amount. That's very tricky. They don't tell you an amount, they just give you. So when they say the same amount, they're really telling you that we're going to have a variable for that. If he spent $120 total, how much did each festival cost? Okay, so we need something that's basically $32 for the first thing, plus $18 for the second thing, plus 2, and I'm going to use the letter F, so that's 2 times whatever the festivals cost. Because it says this word each. They both cost the same. And then that total is going to be $120 for everything. So which one looks something like that? 32 plus 18 plus... It looks like it's right there. So we got the $32 concert, the $18 concert, and then 2 festivals that are the same. And all totals up to $120. Yeah, I think the best answer for number 18 is definitely C. Let's get into problem 19. Okay, 19's a monster. At least it looks that way because it has this big chart and a paragraph and a question. And a lot of students just quit as soon as they see this because they think, well, it's got to be one of these. And they close their eyes and just pick one. The months Danielle has been collecting cards. The cards in the collection. Okay, I'm not going to really try to understand that yet. Danielle started her postcard collection with 12 cards. That sounds... Okay, she starts with 12 cards. She received from her uncle during his trip to France. Okay, Danielle's uncle sends her 4 more cards each month. As he travels for business, the table above shows the relationship between the number of months Danielle has been collecting cards and the number of typo alert, of cards she has. How many cards can Danielle expect to have after 18 months? Okay, so let's unpack this. What it's asking you to do is to write your own equation for what's going on here. So basically, she's starting off with 12 cards, and then we're adding on to that 4 more for each month. Now that term right there, each month, that's going to be our variable. So it's going to be 4, and we'll use the letter M for months, and especially since they told us to. So 12 plus 4M, where M is the number of months. And then we can plug in any number of months we want. So here's how we can check it. The reason they gave us this chart wasn't to give us more of a story. They were saying, hey, use these numbers to check your equation. So like, let's try it for 3 months. 12 plus 4 times 3 months. Now, if we're right, this should come out to be 24. Well, parentheses, that means multiply, so that'd be 12 plus 12 equals 24, and yeah, that makes sense. So our equation works. So this is what we're going to use with these numbers. So what would happen, let me go down here. So what's 12 cards she starts with plus 4 cards for every month when she's been getting cards for 18 months? That's what we want to know. Okay, so that'd be 12 plus 4 times 18. That'd be 4 times 10 is 40. 4 times 8 is 32. So that'd be 40 and 30. That'd be 72. So that'd be 84 cards. And now, is that one? Ha! Yeah. So it looked like a big nasty problem, but really Not that big a deal. The answer for number 19 is A, 84 cards. Now let's get into the last problem of the review, problem number 20. Which equation could be used to solve the problem below? So I'm just going to underline important things as I go. A phone plan charges $15.95 per month. Okay, that'll be important. And 10 cents for every minute M that the phone is used. Mr. Karmsky, oh my goodness. Mr. K's phone bill is $41.55 for the month of September. How many minutes was the phone used? Okay. So his total bill is $41.55. He's got a static charge of $15.95, and then what we don't know is how many minutes he used it. So that'd be something like $15.95 plus 10 cents for every times the number of minutes, and if you added those together, you'd get $41.55. Is there anything that looks like that? $15.90? No. It looks like B. $15.95 a month plus 10 cents a minute, and the bill is $41.55. Yeah, the best answer there is definitely B. And that is the conclusion of the study guide. I hope it's been useful. Please go back and review. Post a comment if there's a question that you still need more explanation for, or if I've said anything that was unclear. I'm sure there was something to complain about. I'll see you next time.